Good afternoon. My name is Usman Shakil. I'm a Principal Solutions Architect with Amazon Web Services. And along with me, Gerald Tu. He is a Professional Services Consultant with AWS. And Matt Janshin, who's also a Solutions Architect with the AWS Partner Team. So we're here to talk about the future of rendering, a complete visual effects studio in the AWS cloud. So let's get started. So we are next-gen render, an imaginary visual effects studio company. And we're going to talk about today, what did we do to actually move our storage, our render farm, and also our modeling toolkits over to the AWS cloud. So just to kind of give you guys a little bit of idea of the scenario that we're trying to build here, next-gen render, our visual effects studio, consists of the three of us. We have about 20 terabytes of on-premise storage, around 10 nodes of render cluster to actually do the rendering jobs, 3 GPU workstations for graphics artists. And what we do is we actually do these visual effects projects for different studios. And given it's all project basis, we cannot really afford to have infrastructure running or large storage farm running all the time or a render farm running all the time. Additionally, we also use the geographically diverse talent, and we want to be able to leverage it as much as possible in our environment. Lastly, there are times when we are challenged with a lot of projects, keeping these environments separately, setting them up and tearing them down really, really quickly is a big challenge as well for us. So our dilemma, we had a project that just came up from Studio Cools, where they wanted us to do 300 plus shots of visual effects content and 2,000 frames per shot. So the three of us sat down and did some math over lunchtime, and we thought that given the resources that we had and the time constraints and all that, it's just simply impossible to have it done given whatever we had. Maybe it'll take 2 years? What did we compute? Something like that. Yeah. So we thought, what about the cloud? Let's think about the cloud. How can we move these resources over to the cloud and go from there? So what were the really moving points that we wanted to look at for this sort of thing, moving our render farm and our storage and everything over to the cloud? So first of all, we don't want to be restricted by any sort of storage limitations that, hey, we're running out of space in our environment. We don't want to be restricted by any form of compute or render capacity. So given the scalable cloud environment, it's great that we can spin up as many nodes as we want for the render, for actual rendering. And we don't want to be restricted by the number of, modeling workstations that we have. And also, given our talent is diversely located or geographically located, we don't want to be confined by that. It has to be pretty low overhead, on-demand type of resources that we can spin up, spin down as needed. And we want to have a complete studio in a box or in a template that we can simply launch. We can expand, shrink, destroy, however we like, just play with it, right? And we want to be very flexible in terms of the type of hardware that we can use, try new things, and it has to be secure, because at the end of the day, we are touching this highly valued content for our customers, and we want to make sure that it is all secure. So these are, our list of components that were going to be needed if we wanted to have, a render complete visual effects studio running into the cloud. So first of all, we needed some kind of a shared file system. So, we looked at Lustre, we looked at the new Avere virtual FXTs that are available now, NetApp, and there are a bunch of other tool sets available from the partner side. On the render farm side, we looked at Arnold, Mental Ray, V-Ray, Mantra, RenderMan. There are a bunch of others that you can run as a render farm. and we are going to be using Arnold for our project. You need something for render job management software. So Deadline, Tractor, Backburner are some of the common names there. For our particular project, we're going to be running Deadline. For 3D animation software, we're going to be running Maya. And last but not least, we're going to have a license server to actually distribute the licenses for the different render farm nodes that are going to be running. And we use FlexLM for our project. So here's a very high-level architecture. So as you can see, well, in this, let's start from the left-hand side of your screen. And S3 is the underlying storage for everything. So we have all our texture files, your script files, all our images, the content, everything lives in S3. That gives us benefit that I'll talk about. And also we can archive it on an ongoing basis. We have CloudFormation templates for the storage tier. We have CloudFormation templates for our render farm, which is running Arnold render nodes. And we have CloudFormation templates for our modeler nodes so that everything is really scalable. And in the cases where we have clients actually providing us with some assets or content, we do go with AWS Direct Connect to actually get access to that on-premise storage, fronting it with some kind of like a storage servers or caches. Our modelers are going to be accessed by our graphic artists via AppStream, or you can also use Amazon Workspaces, etc., and we'll cover that in more detail. So let's first talk about what is the studio-grade storage in the cloud, or how did we do this? So again, going back to S3 being, let's say the storage endpoint for everything. Reason being it's highly durable, it's highly cost effective and fast, and I'm sure you guys are aware of that by now. Looked at different sessions, and you probably played with S3 already. And really the points that I like to mention here is the capability, the infinite scale capability and the infinite storage capability of S3 that you can really leverage for your benefit in these type of patterns where you can have multi-part uploads for parallelizing the writes and range gets for parallelizing the reads, and it works very nicely in conjunction with the hybrid model as well that I'll talk about next. So here is storage pattern number one, where say if you have a render engine that or a software application, whatever have you, that can access S3 directly, then you can really parallelize the throughput up to the capabilities of the instance where your tool set is actually running. So the idea is that you are parallelizing, again, the reads through doing range gets, doing some stuff on it, and then parallelizing the writes, doing multi-part uploads, or in other words, chunking, and then you can scale as much as you like. So given the fact that the S3 front end will scale based on the number of nodes that you spin up or the front end nodes, it basically works to one's advantage greatly. The second storage pattern is Lustre file system that we leverage for our project here. So one of the cool features that I like to talk about here about Lustre is that the guys at Intel, they are going to be announcing a capability pretty soon here. And I did get the clear for them to mention it here. So that is basically at the time of Lustre file system launch, basically you can specify the S3 bucket that your content or your data set lives in. And when it launches the file system, it'll actually bring the directory structure over. So basically it does that prefetch for you. And given that, Lustre's come a long way in terms of, from a high availability perspective, from say feature set, even in terms of say capabilities of VPC, etc. It's really great to see that, you can launch a pretty scalable and highly available Lustre file system with a single CloudFormation template that actually prefetches the directory tree from your S3 bucket that you point to. So what that enables us to do then is make this, so before I go there, so given that it is distributed, right? So I can also add additional storage nodes as needed based on the total amount of storage that I'm going to need. I can also add additional metadata nodes based on the actual number of render farm nodes that I'm going to require. And on an ongoing basis, I can sync it back into S3, so my outputs, my data set is being synced back or being protected or given the durability of S3. So what this really enables us to do is to come up with a new pattern, which is really a disposable file system if you look at it. So as I mentioned before, everything lives in S3. You can archive it into Glacier. And then, given Lustre is using EBS, you can snapshot it back into EBS, and then that is stored as EBS snapshots, and that's stored in S3. All the Amazon Machine images for Lustre are available through the Lustre wiki, and there's a CloudFormation template, as I mentioned. So with that, the sort of pattern that we came up with was basically for every single visual effects project. Just imagine if it's a project from a studio, you're working on full-length animation, etc. Basically, you're creating a project, and that has its own location inside of S3. You're pointing to all the asset files in S3 that are brought in via the CloudFormation template for Lustre. Spin up the Lustre template as needed, scale it, grow it, shrink it, however you need based on, things change inside the projects, right? And once you're done with it, given all your outputs is backed up by S3, you can simply go ahead and delete your Lustre file system. So the idea is that you don't have to really manage it for a long time or keep running it for a long time, because it's all persisted by S3, and you can just use it for the purposes of that project. The second the storage pattern that I'm going to talk about is in the case of hybrid scenario, where say you have an on-premise NAS that's running and has all your content, and it is, given its very large amount of content, very large files, it's hard to actually physically move that stuff over. So what you can actually do is some sort of like a caching mechanism. As I mentioned earlier, Avere just launched their virtual FXT appliances inside of EC2, so you can actually run those in EC2 now, fronting your on-premise NAS. So what that is doing is actually providing you sort of like a cache that your render nodes can have access to. And with Direct Connect, that is also scalable. You can have access to one or multiples of 10 gig direct connects from your on-premise into your environment. So I'll now invite Gerald to talk about the render farm in the cloud.
Thanks, Usman. Sorry guys, I got a little dry throat going on. So as many of you guys know, render farm development is really the cornerstone to any visual effects company. Without the render farm, all those pretty pictures that you see on the screen, they just don't exist. And for production workflows, there's a lot of extreme peaks and valleys for render farm capacity. So AWS is really helpful in the scaling of the render farm. So to create a render farm from scratch, it's a lot easier than you actually think. I use the combination of Troposphere, Bodo, and CloudFormation to create our render farm client clusters. And as you can see, we're able to just create a license server, a render farm manager, and then the client clusters as separate CloudFormation templates. And we're going to be able to grow the size of the capacity of the render farm on demand. By providing on-demand scalable infrastructure, we can optimize costs and provide compute resources necessary to complete jobs of any workload type. And by scaling infrastructure in an as-needed basis, we can eliminate the wait times of the artists. So imagine you're an artist and you have a 2,000 frame job to render overnight, and over 50 machines, this would take the entire night. Rather than doing that, we scale to 2,000 nodes right away, and the artist can complete that job within the time that the render itself takes to render, which could be maybe 5 or 10 minutes. So you're doing this in the exact same cost as you would take overnight, except you get it back immediately. So that means more repetition. That means being able to get to the director's notes faster. That means you're going to end up with a nicer picture at the end of the day. So the other thing that you can think about at this point is spot pricing, right? Because let's say that I'm an artist and I have that same 2,000 frames, and I have now the capability of going to spot instances. So that same job that was 2,000 frames on those on-demand instances are even cheaper now. So this is a huge advantage to a lot of visual effects studios. And as you can see, like with AWS, we're no longer like bound to the time constraints and the resource constraints of a traditional data center. We're only bound by the producer's wallets, really. So let's take a look at the disposable render farm and what it is. So the idea is to have a simple, scalable render farm that can be turned on and off. And instead of purchasing hardware and building out data centers, we create these on-demand clusters of machines that are specifically tailored to our workloads. So when a job is complete, you just tear down the render farm and maintain the render farm manager and license server for ease of historical data and ease of use. For our demo, we used Deadline, like Usman had said, for the render farm manager, and FlexLM for the license server. Each one of the client node clusters, as you've seen here, for rendering, effects, and compositing, can be scaled separately. So depending on how many jobs you have and what types of jobs you're running, you can scale each one as necessary, and you can change the min and max sizes based on the workload. So what about licensing? So today, right now, we can only scale to the number of licenses we have purchased, and this is a problem in like our smaller company. For larger companies, this isn't actually really a problem. Most large visual effects houses, most large animation houses, they have unlimited numbers of licenses. They have unlimited render licenses. They have unlimited render node licenses. So this isn't a problem with them. But once we do have a cloud licensing model for that is adopted, we can actually scale to an infinite number of nodes easily. Now let's just take a quick look at some of the code that was written. So if you notice, this is Python code that I wrote using Troposphere backend, and as you can see, the create role and profile just creates a simple IAM role and profile, and then the function of the create autoscaling group is creating an autoscaling group. As you can see, the idea is to create a very simple and very easy to use function that will essentially allow us to create different tiers of nodes for different workloads. So for example, here we're just taking a configuration file and getting the different instance types. We're taking a configuration file to get the min and max cluster sizes, and we're also getting the security group for all the render nodes in here so that we maintain security throughout all the clusters that we launch. Next, we have the user data used to configure this. And so a lot of like code here, but it's not really that much because this is all of the code that was necessary to configure the render nodes in our cluster. And as you can see, the main things that we're pointing out is like we mount the Lustre file system, we point the Deadline clients to the installers, and we point the Deadline clients to the license server. That's really all we're doing, and we're able to create the render farm cluster nodes very fast. And this is something that would take like months to do back in the day. So bonus points. So spot instances, right? Like we can save more and render quicker by using more spot instances. By having these this Troposphere implementation, we can literally change the way our render farm is priced at any time. We can scale using spot instances, or we can scale using reserved instances, or we can scale using on-demand instances. It really just depends on what we're doing and when we're doing it. And so with Troposphere, you're literally just flipping a flag in Python to say, use spot instances. We have all the configuration set in the background to say like the pricing and whatnot, and you're done. So one thing that you should also know is that the Spot team has recently announced that they are going to be giving a feature that gives a 2-minute warning to all users when a Spot instance is terminated. So this actually gives you more time to you have more time to terminate your instances or move workloads into different areas. So as you can see, by simply changing this stuff, like we can handle workloads of any size, and we can really use like any pricing that we want to do. So next I'm going to hand it over to Matt, and he's going to talk about the 3D modeling software.
Thanks, Joe. So some of you in the room may already be doing some render jobs in the cloud. And what's important is until now we've been doing something that some people would call headless. And in other words, there's no UI necessary. You know, we're running this stuff, we can script it, we can run it without a visual interface on top of it, and we can automate it with scripts. And this is extremely important. But what happens in something Gerald said if you have multiple passes? You know, you've started to use spot instances, you've scaled out to 2,000 nodes, and you're starting to do sort of micro edits to your scenes. You want to add a little more light here, you want a little more wave here, add some more wave here. Do you want to move the asset, move the scenes to and from on premises every time you do that iteration? No, because that kind of defeats the purpose of being able to do these quick iterations. Secondly, something that Usman said at the beginning, we are more and more working on a project that we're actually working on, not next-gen render, but a real company right now. We have people in California, Seattle, Montreal, New York, and I think there's some guy in Estonia who's actually the artist. And this is more and more common. You know, we're farming out work. It's very specialized work. You know, a lot of you work in this visual effects industry or in this media industry. It's hard to find talent, and this talent isn't always next door, certainly not the seat next to you. And it's not always possible to have huge workstations powering, you know, just available to you. Real world scenario number 2, I was on the beach, you know, enjoying a pina colada, and you get a call like, hey, could you spin up a cluster? Or another real world scenario, I was on the plane the other day and fat fingered something without turning on termination protection, and because of go-go in-flight Wi-Fi's latency, and I was getting frustrated and tapping, and I shut down a whole 200-node render farm and a bunch of other stuff. And so you're not always able to be near the tools at your disposal. So what do you do? And especially for the creative thick clients, this is where it gets hard. You know, I can SSH using go-go from the plane and spin up 200 nodes because Amazon's amazing, sure. But what about changing the lighting on a 2,000 scene or 2,000 frame scene? You know, that's a little harder. You're not going to pull that off over go-go today, right? So this is where Amazon comes in and where the G2 instances come in and where AppStream comes in. So yes, you can spin up render farms, you can spin up disposable file systems, but what about the actual creative clients, the 3D modeling tools, things like Maya, Cinema 4D, 3ds Max, all these tools that we're using to actually do the artist's work? Well, there's a problem. You could use them over remote desktop or VNC, except you can't, because they require DirectX, they require OpenGL, they require a graphical user interface like Windows or sometimes on Linux, and they need a card that has a GPU in it and an ability to use DirectX and OpenGL and whatever, and you can't do that over the standard remote desktop protocols. Also, those protocols are kind of slow. I don't know if you ever tried to use any of these clients over VNC. Try do scene editing, you know, with Maya over VNC from, you know, the beach. Not ideal. Colors off, a lot of jitter. So 2 problems really. Getting boxes with GPUs in them and getting software that has low latency, high performance that can support DirectX and OpenGL. So at Amazon, we have the G2 instance types, and that solves the GPU problem. These are, you know, relatively beefy boxes. And importantly, they have a NVIDIA card inside of them that you can leverage. The second piece of the puzzle, and this is where it gets really cool, is AppStream. And AppStream allows you to run applications on Windows that supporting DirectX and OpenGL to effectively stream them to you. So you can think of it like a video and an audio stream, but it's an interactive stream. And you can use it over an iPad or a thin client or your laptop or whatever. And when you click and drag, it sends those interactive actions over a proprietary custom protocol that works really well in high latency situations to and from the GPU-backed instances in the cloud. Importantly, the color is also a lot better, and the quality of the audio and the quality of the video. So it's aimed for people in the engineering space, people in the media space, et cetera. So digging a little deeper into the protocol, we use something called the STX protocol, which is a proprietary protocol that we developed. It really just uses H.264 over UDP to get that high quality, low latency video feed. It supports Opus audio and H.264 for audio, so good dual channel audio. And it encodes all the time, it's constantly adapting. So as your latency changes, as your performance of your link changes, STX adapts with that, and it's much, much better than, for example, using remote desktop or using VNC. You can run AppStream in 2 ways. In standalone mode, which is sort of like what you may be used to with workspaces today, where you actually stream the entire Windows desktop. This is a relatively new feature of AppStream, so you might not be aware of it. And in the demo we're going to show you in a bit, that's what we're doing. We're actually streaming the entire Windows desktop, so you don't actually have to have an AppStream-enabled application. We're running stock Maya 2015 in this demo. You run 3ds Max, you can run whatever you're using. It'll just work. No changes needed. Just has to run on Windows. It'll leverage the GPU on the back end, use DirectX, all the other stuff. So what you're going to see today is a streamed Windows desktop. Really easy way to get started. Sort of phase 2, and somewhere where we'd like to move with a lot of these creative applications is, like take Maya, for example. You have the viewport in the middle. That's the part that's doing a lot of the, you know, from a artist perspective, all the 3D heavy lifting. Or maybe when you do a render, you quickly do a quick render of a frame. So that's the part that you need the 3D, the GPU heavy lifting for. So AppStream in the hybrid model allows you to take components of your application and use AppStream for only those. So on your iPad or on your laptop, you have your client running, but the piece, like the viewport piece, the render piece, farms those AppStream. You have like Kindle or an iPad or whatever running a full-blown creative client and heavy lifting out of the instance via. That's kind of the best way to do it. So it's less push the whole lifting step up. Security is also important. So you're going distributed standards, Montreal, California, or OEM. How are you going to lock it down? How are you going to part of it? That's why I'm tied into you are part of our no longer part of our team. If you have a distributed team, you don't want to log things off. All of the whatever the taking a little step back and tying it into the other stuff that Gerald was talking about. Once you have this S3 backed file system, today we're going to show you Lustre that we're hydrating from S3. And once you have the render farm that we're spinning up using Spot instances and EC2 instances, in this case Arnold, you can front it from a visual perspective with a Windows instance backed by a G2 instance backed by a GPU that can run Maya, can run the deadline monitor, can run all sorts of other tools to not only coordinate your render job, but also do things like make a lighting change. And what we're going to show you in a second is an actual real example that we put together with our friends at Autodesk, where we make a change to a scene. We're from the beach. Well, I don't know if Lawrence was sitting on the beach when he did it, you know, certainly he wasn't working on a big workstation. He was farming that workstation heavy lifting off to Amazon. So Usman will take you through, start to finish, not just the Maya sort of lighting part, but also how we build this up with the templates themselves.
Thanks, Matt. All right, so as Matt pointed out, we worked on this demo along with our friends from Autodesk. And really what it is going to be, it's 3 parts. I'll start with how do you create a disposable file system with Lustre, go through the CloudFormation template. Then the second part is going to be a disposable render farm, which I'll cover again with the help of CloudFormation template that we put together. So the idea is that everything is, you know, it's basically a single CloudFormation stack deploy, and it has all the components in there that you can scale as needed. That's the whole idea. And then once you're done, you just simply terminate those, and that's done. Everything is backed by S3. And then finally, the third piece is going to be actually using that AppStreamed instance that also, by the way, has access to our Lustre file system via a SMB mount. Then actually doing some lighting effects or changes to a scene. All right, so with that, let's take our studio to the cloud. So here, as I mentioned before, the first piece is going to be the Lustre stack creation. And as you can see here, this is our CloudFormation template that the guys at Intel provided us. And the different parameters that it talks about is the most important one I'm going to talk about here is the import bucket parameter that they have exposed. So the idea here is that we are pointing it to a bucket, in this case, Mayan-reinvent, and to a folder within the bucket. Also gives us the capability to define the type of instances that we want to choose, the number of nodes inside our storage, Lustre storage number of nodes, and the Lustre metadata nodes. And once it's completed, it also gives us a nice dashboard that, again, the Lustre guys have created, that gives us the status of all the underlying nodes, so you know if the file system is up and running. So here, you see in the S3 console, the S3 bucket that we pointed to, and all the content is in that S3 bucket. And now going back to our EC2 console here, basically you see there are different nodes that are launched as a part of the Lustre CloudFormation stack creation. Since everything is inside a VPC, inside a private VPC, the way to access those is over VPN or the batch network. So in this case, you know, we're going to launch a batch network, which is a public kernel that points to Lustre. So in here, I'm doing an SSH from a terminal window into that network. Here, I'm going to be pointing to the Lustre client code. And what I really want to show here was that, you know, that the S3 bucket that I showed earlier that had all the content, how that is visible inside the client, which is the So doing SSH into the That's also basically the based on the template, the CloudFormation template. And again, as Gerald pointed out, and he showed you a little bit of code. In this case, don't try to read earlier, and it's kind of tiny. But the idea is that everything is put inside the user data space. So when we render how to point to the license server running for our render farm, and then finally how to mount the Lustre file system. So yes, it's pointing to a single endpoint for the Lustre file system for a single metadata. At the end of the day, keep in mind that it's all distributed. So there are multiple metadata servers that are, say, the front-end servers for the Lustre, that are basically the Lustre file system. So then once the CloudFormation template is complete, you can see that all the render farms nodes are created. In this case, we had 36 nodes, actual nodes that we launched for our render job, because we are trying to render 36 frames. So the idea was that we will actually render one frame per node. And after the CloudFormation template is run, all the nodes are available to us. The next up is I'll invite Gerald here to talk about how we are actually doing the modeling.
Thanks. Thanks, Susan. So this is really just jumping right into this. And so thanks to our friends at Autodesk, Lawrence was filming this as an example of what an artist would be doing. So let's say an artist is at his laptop in dailies, and he's got a note from Shotgun saying, hey, this character needs some more sun on his face. So rather than going back to his desk or going to, like leaving the dailies room and missing the rest of the daily session, the artist can literally launch AppStream from his laptop or launch from his iPad and say, okay, I'm going to just fix this really quickly. And maybe by the end of daily, or even before then, the render will be complete and I could re-show it to the director. So this is a great example of how that works. So as you can see, Lawrence has launched the AppStream instance at this point. And one thing we should note is that Autodesk did help us a lot on this. They gave us all the data that we needed. They gave us, obviously, Lawrence, who was the artist, because I don't think any of the three of us could do that without him. And so he's going to be showing off, like, just opening up the file through Maya on the AppStream instance itself. So as you can see right now, he's already opened Maya on the AppStream instance. He's about to open his scene file. This is running with the Lustre file system. So he's actually loading these files from Lustre via between Windows and Linux. We were able to run this hyper-environment very easily. It wasn't hard to set up at all. And so right now what Lawrence has done is he's done a preview render within the AppStream instance itself. And because this is a G2 2 extra large box, you can see the graphics and processing abilities of this instance have really helped out. And he's able to see the character with more light on his face immediately. Like it literally took, I think about like 10 seconds once he clicked go. And so now he's changing his render settings. He's getting ready to launch a full-on render for the Deadline client. And we can see like through this that it's actually very simple, like for the artist to do this from their laptop or whatever. They don't need that really heavy usage graphics box at their desk or anything anymore. They could do this from anywhere. Maybe he really was in like Boca or something like that. Probably was.
Hope so.
Lawrence is now showing or kind of giving us a little example that there's nothing up our sleeves. Is like opening up a new folder, making sure that we have a new version of the file before saving. And he's actually going to launch through Deadline from the Maya interface itself. So Deadline has a Maya toolbox, so this makes it very simple for us to launch through Deadline. change the render versions and change all the settings as necessary. And yeah, well, so we can just watch and do as we'll work here. And so this is the now empty folder that I was mentioning. He's just making sure that we're not pulling one over on you guys. This is a completely brand new render. And so to give you guys a little bit more background, the render blades that we're running on are C38XL blades. So these are going to be rendering hopefully as fast as the high-end workstation blades. And according to the Autodesk guys, as you'll see in a bit, that they actually do run around the same time frame. So now Lawrence has submitted the job through Deadline. He's opened up the Deadline monitor in the AppStream instance itself, and you can see that all the render nodes picked up right away for these 36 frames. And like Usman said, these 36 frames we chose just because this shot itself was only 36 frames. Had it been a 2,000 frame shot or a 1,500 frame shot, we would have just spun up more instances, and this would have picked up in the same way. And because of this, it's actually, because we're doing all this in parallel, all the frames are going to come back at the same time. And so as you're watching this go through right now, he's going to essentially look through the logs through Deadline just as he would as if it was on his own box. Make sure that things are running okay. And he's going to notice that all the frames are going to complete right around the same time too. So you'll see now that the frames have started to complete, the task progress bar will just kind of fly across. So like you said, it's about 3 minutes and 40 seconds for each one of these frames on these C3 8 extra larges. And according to Autodesk, that was pretty much equivalent to their high-end render blades. So that was a great test for us to run through. So now that the render is complete, he's actually going to show us the completed render on the AppStream box itself. We didn't install RV or a playback client. Otherwise, we would actually be able to show you this in at frame rate. But this is just using Maya's playback tool. As you can see on the bottom, I don't know if you can see it's kind of small, but AppStream itself gives you a frames per second of the instance itself. So you can see that this is pretty much staying at around 30 frames a second, plus or minus a couple frames. And so what's happening right now is why you're not seeing it in real time is that it's just buffering the images from the Lustre file system onto the node. But the instance itself is running at over 24 frames a second. So now the frame is complete, it's automatically populated back in the shotgun. Lawrence is looking back in shotgun, he's like, okay, let's play this back there. Make sure that everything that I wanted was there, and you can see that, hey, there's more sun on the character that we wanted. So it looks like he's happy with that. He's going to make a note, and that's it.
All right. Thanks, Gerald.
Yeah.
All right, cool, right? So with that, let's talk about a little bit about the performance of this whole thing that we put together. So really, at a very high level, it's pretty simple. So this is like, in general, a very high level sort of, say, architecture, if you will. You have S3, you have your Lustre file system, or your disposable file system, as we like to call it, the render nodes, or the render farm, your storage cache, if you want to do your on-premise storage as well, and direct connect. So the idea that we're trying to mention here is that given the scalability of each one of these components, right, you're not really confined to a specific I/O performance that is, or network performance that is, or whatever. So really, depending on the number of render farm nodes that you're going to have, each node is running on an EC2 instance. In our case, we use the C3 8 extra large. C3 8 extra large has access to a specific underlying network throughput, right? And given the characteristics of S3, if you're parallelizing the reads and writes, you can pretty much saturate the network interface of that C3 8 extra large, going straight to S3. Now, if you're putting Lustre in between, then you have to basically calculate the number of Lustre nodes that you're going to need, the storage nodes, the metadata nodes, based on the amount of storage and the performance. And going back again, Lustre is on EC2, depending on the type of the instance that you have, has access to a specific network throughput. And with that, you can pretty much saturate the network interface for each one of these Lustre nodes. Same goes for the storage cache. So as I mentioned, Avere earlier, so they have an Amazon machine image available for their Avere appliance that you can run on EC2, front your on-premise NAS. And again, that is running on an EC2 instance, really, right? And say if you have a 10 gig direct connect that's available to you from on-premise, you can launch multiple of these Avere nodes. So in this case, let's say if it's an C38 extra large, without any specific numbers here, but you could have 10, 12, however many Avere nodes running, and that could really saturate the link that you have available to. So the idea is that this disposable, highly scalable sort of architecture for all these different tiers for a visual effects studio really comes in handy in type of projects, where it's sort of like, say, temporary or on a project by project basis. So great. Going back to our next gen render, we delivered the project on time and under budget. Yay. And yeah, with this, we're on to bigger projects with a fancy visual effects studio in the cloud. Well, thank you very much. Please definitely put give us some evaluation or fill out these evaluations. And I also like to mention for Q&A, the three of us will make ourselves available. If you have any questions, feel free to drop by. We'll just hang out here. And lastly, there is a happy hour that we are hosting. Have a drink on us. It's in Venetian Suite 34117. So if you guys are interested, have time, please drop by. It's at 3:30, from 3:30 to 5:30 at Venetian 34117. Thank you very much, and have a good rest of your day.